Physics chapter 17, theory video 9, Newton's second law of motion. Now we have two equations for centripetal acceleration, that is A equals V squared upon R. Then also we have A equals V omega, that also you should remember. And also we deduced in the question A equals omega squared R. So using these two and using Newton's second law, we can deduce other equations to find out centripetal force. Now F equals ma, F equals ma, we apply that, and using that we can figure out two more equations for F. So we substitute, instead of A, we substitute these two equations. A equals V squared upon R, then we get mv, instead of A we put A V squared upon R, then we get F equals mv squared upon R. Then in the second equation we can take A equals omega squared R. So instead of A we put omega squared R, then we get F equals ma, instead of A we put omega squared R, then we get ma omega squared. So these two equations, that is F equals mv upon R, mv squared upon R, and ma omega squared, those two equations you must remember. Now please write a note on that first before we move on to the other part. Using Newton's second law of motion, we can derive at two equations for centripetal force. And then write down F equals mv squared upon R and F equals ma omega squared. So these two equations you must remember. And if you did not understand why and how that came, please refer to these two equations. We substituted the values for these two equations. Instead of A, we put in F equals ma equation, we put these two instead of A. Right. Then put a star and write down. The acceleration as well as the resultant force are in the same direction, that is towards the center of the circle. Towards the center of the circle. Right. Now we are going into another very important calculation, and this is something that usually comes for the exam. Calculating orbital speed. Now, according to Newton's thought experiment, he suggested that if something is fired up or fired at a certain velocity or speed, it will go the complete circuit, or it will go into orbit. So now we have to figure out how to put things into orbit. So because we have put so many satellites in the sky into orbit, they are in orbital as we speak. The video is brought to you by such satellites. So then, using the data that is available for us, we can figure out what is the speed that is required to be given to a certain object at a certain height and of a certain mass. So now, the necessary centripetal force F equals mv squared upon R, that is one equation we got. Because F is the centripetal force is Earth's gravity, that is mg. Mg is going to be equal to mv squared upon R. G is equal to then v squared divided by R, because m to m gets cancelled out. We know the value of G, 9.81 meters per second square. So then if you consider now, the radius means from the center of the earth. So that is about 6,400 kilometers. Then close to the earth's surface, to find out the speed that is required, we can put the details that have been given. G we know 9.81. V squared is what we are trying to figure out. R we know. R is 6.4 into 10 to the power 3 kilometers, again into 10 to the power 3 to get meters. So 6.4 into 10 to the power 6 in meters. When you simplify this, you get V to be equal to 7.92 into 10 to the power 3 meters per second. So that means if you fire something at a speed of 7,920 meters per second, that is, if it travels approximately 8 kilometers per second, then it will go into orbit around the earth. Thus, if you were to throw or hit a ball horizontally at almost 8 kilometers per second, it would go into orbit around the earth. So that is basically the idea. So I hope you understood that. Using this, we have to do questions. Before we go into the next video, please do question number 14, 15, 16, 17 and 18, and then we will discuss the questions.